For centuries, we've been told the universe is all about abstract math and forces we can't really see or touch. But what if that's not the whole story? What if the cosmos isn't some ethereal equation, but a physical machine? A brilliantly designed engine. Let's pop the hood and take a look.
And that's really the big question, isn't it? Do we stick with the mathematical models that, let's be honest, sometimes break down at the extremes? Or do we look at the universe through the eyes of an engineer? Through the world of pressure, tension, stress, and things that have real, physical properties.
So the framework we're digging into today comes from the work of Mukesh Vidyabhushan Singh. He's a mechanical engineer, and he did something pretty radical. He applied the principles of material science, the stuff you'd use to build a bridge or an engine, to cosmology itself. And it all started with one simple, powerful question. What if the fabric of space-time has physical properties, just like a chunk of steel?
Now this right here, this is the foundational claim. And you gotta let it sink in, because it flips everything we think we know on its head. The idea that space isn't empty, that it's actually the most solid, most fundamental material in existence, well, that's the key to understanding this entire engine.
Okay, so let's start with the foundation of the machine, the engine block itself. To get this model, we first have to totally rethink what we mean by empty space.
This physical medium is called the universal lattice. And here's the kicker. Particles don't just exist in space. They're actually constructed from it. The lattice isn't the box everything sits in. It's the raw material everything is made out of.
And we're not talking about some flimsy fabric here. This universal lattice is described as being hyper-rigid. Think of it like a spring that's been pulled incredibly tight, holding just a massive amount of tension. To give you some perspective, its stiffness is calculated to be way, way greater than anything we know. Yeah, even stiffer than diamond. This is the structural frame holding the entire universe together.
Now, I know what you might be thinking. Hey, this kind of sounds like that old ether theory, right? But there's a huge, crucial difference. Back in the 19th century, physicists were looking for a thin gas, a sort of cosmic wind blowing past us. The universal lattice is the complete opposite. It's an incredibly rigid solid that we are made of. The reason we don't feel it is because we're part of its internal vibration. It's like a fish in the deep ocean. It doesn't feel the crushing pressure because it's part of that system.
Okay, so if space is a physical material, then moving through it has to have some real consequences, right? Of course. And this brings us to a totally wild reimagining of what mass, inertia, and even time itself actually are.
Get ready for this one. What if time, as we know it, isn't a fourth dimension that we're traveling along? What if it's just a measurement of mechanical resistance? The friction of the universe's engine running. It's just drag.
Let's make this super simple. Imagine a clock. You put it in a bucket of water and it ticks along just fine. Now take that same clock and shove it into a vat of thick, gooey molasses. What happens? Well, its gears physically struggle to turn, and the clock slows way down. Its time is dictated by the viscosity, the thickness of the medium it's in. In this view, time dilation isn't some abstract warping of a dimension, it's literally the gears of your atoms getting bogged down in a thicker medium.
So this totally reframes what mass even is. Mass isn't something a particle just has. No, it's a measurement. It's how much friction, how much drag that particle's structure creates as it moves through the lattice. So heavier objects, they just have a higher drag coefficient. And inertia, that feeling of resistance when you push something, that's just the physical pushback from the lattice itself. It's simple mechanics.
So what's causing this molasses effect? What's making space thicker in some places? Well, that would be gravity. In this model, a massive object like the Earth doesn't pull you down with some spooky force. Instead, it creates a high-pressure zone, a squeeze in the universal lattice. And that squeeze makes the local fabric of space denser and more viscous. And that's exactly why time physically slows down in strong gravitational fields. The molasses just got thicker.
So we have our engine block, the lattice, and we have the system's drag, time. Now let's get to the transmission, the gears that actually transfer energy across the cosmos. This is where we get a beautiful mechanical explanation for light and electromagnetism.
What's so elegant about this idea is that the electric and magnetic fields stop being these mysterious forces. It's simpler. The electric field is just a linear push on the springs of the lattice. And the magnetic field, well, that's the twist, the torque, that naturally has to happen around that push. They're like a screw and its thread.
Think about it. You can't turn a screw without it also moving forward. You can't have the push without the twist. They are two parts of the exact same action. And in the same way, the electric and magnetic fields are totally inseparable. They're just two different descriptions of a single mechanical event happening within the same structure of the universal lattice.
And this right here gives us a physical reason for the speed of light. See, C isn't just some random arbitrary speed limit. No, it's the engine's optimal operating speed. It's the sweet spot RPM where the push and the twist, the electric and magnetic gears, hand off energy to each other with perfect, 100% efficiency. If you tried to go any faster, the structural integrity of the lattice itself would fail. It's a material limit, just like any material in our world.
Okay, let's move on to the final part of this blueprint. And honestly, this might be the most profound piece of the whole puzzle. We've built the engine. But what about us? What about the person observing the engine? Let's talk about the thermodynamics of consciousness.
This is what philosophers call the hard problem. Science is great at explaining how the neurons in our brain fire, but it has no real explanation for why we have this subjective internal experience. But from an engineering perspective, well, a high-performance system doesn't produce something as incredibly complex as awareness by accident. It must be part of the design.
The proposed answer is as simple as it is stunning. Consciousness isn't some separate thing, some ghost living inside our skulls. It's an output of the system. Just as a car engine, when it's doing work, generates heat, the universe, when it's doing work, generates awareness.
That's right. Consciousness gets a thermodynamic definition. It is the internal energy, the warmth, if you will, that's generated when the work of the universe, whether it's a light wave or a sound wave, gets absorbed by a sensor, like our eyes or our ears or our brain. We are the part of the system where the universe's kinetic energy literally becomes the feeling of awareness.
This idea can even be expressed in a proposed formula. Don't worry about the math, just look at the parts. Our awareness, C, is a result of the work being done by the universe's vibrations, interacting with our sensors, all happening within the local viscosity of time. So in this view, a more intense experience, more joy, more pain, is literally your system generating more internal thermodynamic heat.
So let's step back for a second. Let's get out from under the hood and look at the whole machine from the mechanic's point of view. Let's take the view from the garage.
So here it is, the complete blueprint. It really comes down to 4 key ideas. 1. The fabric of space itself is the engine block. 2. The speed of light is its perfect balanced operating speed. 3. The whole universe exists in this grand cycle of tension and release. And finally, number 4. Our own awareness is the heat that the engine produces. It's all one single, fully integrated closed-loop system. Ultimately, a model like this isn't about having all the answers. It's about giving us a new way to look at everything. It's about trading abstract mystery from mechanical integrity. And it leaves us with a final provocative thought. It encourages us to have the courage to look up at the stars, and not just ask why, but to ask, like a true mechanic, how do the gears mesh?